Welcome to Edexcel International A-Level Mechanics 1. This is Mr. Minables and this is question 3 from the January 2023 exam paper. A particle P is moving with constant acceleration, negative 4I plus j meter per second squared. At time t equals 0, P has a velocity 14I minus 5j meter per second. Find the speed of P at time t equals 2 seconds. Find the size of the angle between the direction of I and the direction of motion of P at time t equals 2 seconds. At time t equals t capital seconds, P is moving in the direction of vector 2I minus 3j. Find the value of t. So this question is about constant acceleration, which is SUVAT, and about vectors. So let's start from the beginning. We have the particle is moving with constant acceleration. So we have our acceleration, which is negative 4I plus 1j. I prefer to write it as a column vectors. At time t equals 0, P has a velocity 14I minus 5j. This is our initial velocity. So we have u, which is 14 and minus 5. And we need to find the speed when the time is 2 seconds. So we have t is 2 seconds, and we need to find our final velocity. Let's apply SUVAT. So we have v equals u plus at. Our final velocity, this is what we need. Initial velocity, 14 minus 5, plus acceleration, which is negative 4 and 1, multiplying by the time, which is 2 seconds. So this is equals, we have 14 and minus 5, plus 2 multiplying by negative 4, negative 8, and 2. Let's add these two vectors. So we have negative 4 minus 8, this is 6, negative 5 and 2, that's negative 3. So this is the velocity at t equals 2 seconds. The question is asking for the speed. The speed is the magnitude of the velocity. So to find the speed, speed is the magnitude for the velocity. So it will be the square root for the I component squared plus the j component squared. So it will be 6 squared and negative 3 squared. That will be 36. 36 plus 9, which is the square root of 45. And 45 is 9 multiplying by 5. The square root of 9 is 3. So this will be 3 root 5 meter per second. Or we can write it to 3 significant figures or 2 significant figures. So this is our speed when t equals 2 seconds. Let's go for part B. The question is asking to find the size of the angle between the direction of I and the direction of motion of P at t equals 2 seconds. The direction of motion of the particle, this is the direction of the velocity, which means I need to find the angle between I and that vector. So if we have here a sketch, so we know that our velocity is 6 and negative 3. So our velocity is 6I minus 3j. So if we make like a sketch, that direction is I. This one here is negative I. The positive y-axis is positive j. The negative y-axis is negative j. I need to find the angle between I and that one. Let's sketch this vector. So starting from 0, 0, I need to go 6 to the right. So this one is 6 and 3 down. And this one here is my direction. That is my direction. I need to find this angle here or that one. it's either this angle, this is the angle between that direction and that direction, or that one here. Let's apply SUVAT. I have here the opposite. I have here the adjacent. So we can use TOA. So the angle that I'm looking for, which is theta, will be tan inverse opposite over adjacent, which is 3/6. Let's calculate this one. So we have tan inverse 3/6. So we have it as 26.6 or 27. Or 27. That's one angle. Or I can write that one. It's the same thing. This one here will be 360 minus 27. 360 minus 27, which is 333. So it's either one of them, it's correct. I can say here or 360 minus 27, which is 333 degree. So it's either 27 or 333. And this is part B. Part C. At time t equals t capital, P is moving in the direction of vector 2i minus 3j. Find the value of t. So let's find the direction of my particle. And we know that the direction of the particle is the direction of the velocity. But this time I need to find the velocity when the time equals t seconds, capital T. So let's apply SUVAT one more time. So we have the acceleration is -4 and 1. Acceleration is -4 and 1. Our initial velocity, it's 14 and -5. And this time, the time is capital T, and I need to find the final velocity. Let's apply SUVAT again. So we have V equals U plus AT. So we have V equals our initial velocity, which is 14 and -5. Acceleration is the same, -4 and 1. And this time multiplying by the time, which is capital T. Let's write this one as one column vector. So it will be 14. T multiplying by -4, it's -4t. So we have 14 minus 4t. This is the I component. T multiplying by 1 is t. So we have -5 plus t, and this is the j component. So this one is the velocity when t equals t seconds. The question says that the particle is moving in this direction, 2i minus 3j, which means the direction of my particle, which is this one here, is parallel to the vector 2i minus 3j. These two vectors are parallel. To solve this one, let's understand first what is the meaning of parallel vectors. So we have parallel vectors. Parallel vectors from IGCSE, we know that they are multiple of each other. What does that mean? For example, like if I have a vector, let's say it's 1i plus 2j. This vector is parallel to the vector 2 and 4. Also, this vector is parallel to 3 and 6. All of these vectors are multiple of each other. They are parallel vectors. What do I notice about all of these? The I component divided by the j component for all of them are the same. This one here, it's 1/2. It's the same as 2/4. It's the same as 3/6. Which means if I have two vectors are parallel, the I component divided by the j component for the first vector is the same as the I component divided by the j component for the other vector. Let's apply it in our question here. I have these two vectors are parallel because this is the velocity and the particle is moving in that direction, which means these two vectors are parallel. Let's apply it. So we have 14 minus 4t divided by minus 5 plus t. This one equals 2 divided by negative 3. I over j equals I over j. Now I can solve this equation to find the value for t. Let's cross multiply. 2 multiplying by negative 5 is negative 10 plus 2t. Negative 3 multiplying by 14, that's negative 42 plus 12t. Let's move this one here and bring this one here. So now we have negative 10 plus 42, that's 32. 12t minus 2t, that's 10t. Divide by 10, so t equals 3.2. And we don't need to write the units because we are finding the value for t. We are finding just the value for t. T here, it's already have the unit seconds. So our final answer is just t equals 3.2.